5 right triangles. Lesson 5.4, Inverse SOH CAH TOA, solving for angles.
All right, students, that was one of my favorite people on this campus, my former teacher's assistant and a senior on her way to university next year, Adele Yu. Thanks, Adele, for the introduction. Students, we're doing right triangles. You should be getting a help here with a sign-off. Don't forget that. We're going to use our right triangle toolbox to do these 5 problems. So get out your right triangle toolbox. You're going to do 1, solving for radicals, Pythagorean theorem. 2, solving with using 45, 45, 90. 3, solving with 30, 60, 90. 4, and SOH CAH TOA. Ready? Solve these and then come back. Okay, students, did you actually pause and do this on your own, or are you just waiting to copy? I hope you're not waiting to copy because I really want you to do this on your own. Okay, so solving for radicals here. Okay, it looks like there's something missing. So I just now figured that out. If it's missing, you don't have to do that one. Sorry about that. I guess my diagram didn't get far enough over. This one, this is leg root 2. So you should have 9 root 2 over 2 here. Then this is times root 2. So I'm going to show it in the margin. 9 root 2 over 2 times another root 2. That's going to be 9 times 2 over 2. The 2's cancel. So this x right here should just be 9.
Please report to the junior high office. Riley Sandori to the junior high office, please.
30, 60, 90. Short leg root 3, short leg times 2. So we do this. And this way, going this way, 3 root 3 times root 3, that's going to be 9. And then 3 root 3 times 2, that is 6 root 3. SOH CAH TOA, we ask ourselves what you have and what you need. There's your angle. That means we have the opposites. And we want the hypo. We got an OH combo. So we're going to do sine. Sine of theta over 1 equals opposite over hypo. Our theta is 53 degrees. Opposite 15 over our hypo, which is x. We cross multiply. We end up with a sine of 53 degrees times x equals 15. So we have x equals 15 divided by the sine of 53. X equals 15 divided by the sine of 53. Take it second, 18.78. So last class, we used what's called SOH CAH TOA by itself to find side lengths. Today we're going to use something called inverse SOH CAH TOA, inverse, to find angle measures. Trigonometry, inverse sine, inverse cosine, inverse tangent. Another word for inverse used in some textbooks is the word arc. Arc sine, arc cosine, arc tangent. What have we learned so far? Pythagorean theorem. Have 2 sides, mean third side, sag. 45, 45, 90, leg root 2. 30, 60, 90. Short leg root 3, short leg times 2. Then we have So Ka Toa. That is 4 are our 5 tools. This regular SOHCAHTOA is used to find a missing side. What if you have the sides of a triangle and you want the angle measured? That's where we use inverse sine, also known as arc sine. And you're going to be seeing this on your calculator. Inverse sine, that's sine -1, inverse cosine, and inverse tangent. To use this, given a triangle, you label opposite, adjacent, and hypo. You're still going to do have, need, do, but this time we're going to use on the right-hand side of your reference booklet this side called inverse SOHCAHTOA. It's actually very easy. Let me show you the comparison. I like you to write these next to each other so you can see them. To find a side, we use sine of theta over 1 equals opposite over hypo. Notice this equation. Sine of theta over 1 equals opposite over hypo. That's what we use sine to find side. Inverse sine looks like this. Inverse sine, opposite over hypo, gives us the angle theta. The cosine, you know, cosine theta over 1 equals adjacent over hypo. Again, you use that to find sides. When you want to find the angle, you use inverse cosine. Adjacent over hypo equals the angle theta. Tangent over 1 equals opposite over adjacent. Again, you use this to find sides. When you want to find angles, it's inverse tangent, opposite over adjacent equals the angle theta. Now on your calculators, this is the only time you're going to be touching that what's called the second function button. In some calculators, it's the shift button. Make sure you can spot that on your calculator, second function or the shift. You only use this when you're looking for angles. This is easier than you think it is. We want to find this angle. It has a question mark. I'd like you to put in the variable theta, because that's the variable we use for angles. Now from that theta, this is the opposite side. This is the adjacent side. We want the angle theta. How do we choose which one to use? We look at our combination. We have opposite and adjacent. We have an OA combo. Which one goes with OA? Tangent. We're going to write exactly that down. Write it down with me. Inverse tangent opposite over adjacent equals angle theta. Now we circle plug tuck. Inverse tangent, our opposite is 22. Our adjacent is 34. That's going to give us our angle theta. Look what we have there. Inverse tangent 22 over 34. Let's recopy this down here so you can see how this works with the calculators. I will show you the calculators in real time as well. Okay, so it looks like this. we have inverse tangent 22 over 34 is going to give us our angle theta. So two ways to do this on a calculator. Make sure you're in degree mode for the big calculator. Okay, so again, it is inverse tangent 22 divided by 34 to get the angle. We're going to do the large calculator first. The way you get inverse tangent is you do second function tangent. Notice the -1. 22 divided by 34. Close it up. Enter. Now for degrees, I'm going to allow you to do the nearest whole degrees. No decimals for degrees. It gets too ridiculous. So it says 32.9. We're going to call this at 33 degrees. On the smaller calculator, you do the other direction. Watch 22 divided by 34. Hit the equal sign. Then you do second function tangent. Make sure you're getting the exact same thing on your calculator. Again, on the big calculator, that was the second function tangent, 22 divided by 34. This calculator, 22 divided by 34 equals second function tangent. Either way, we just got our degrees for our angle. And our theta is 33 degrees. Let's do a couple more examples. Example 2. We're going to find all the angles in this triangle. So our theta is here. And from that theta, let's label. That makes 42 the opposite. That makes 40 the adjacent. And that makes 58 is our hypo. You're like, wait a minute. I have all three. Now what? Well, you actually can use any three of them. We're going to do this all together so that you can see that you can use all three. So this one time you're going to use all three. But normally, once you realize that you have a choice, you may choose whatever feels most comfortable to you. But I still want you to follow me all three times this one time. Ready? Inverse sine is going to be opposite over hypo. So space. Inverse cosine, adjacent over hypo, space, gives you theta, and then inverse tangent, opposite over adjacent gives you theta. We're going to do all three so that you can see it works all three times. So right underneath, we're going to go inverse sine. Our opposite is 42 over our hypo, which is 58. So inverse sine, 42 over 58. Calculators. Second function, sine. 42 divided by 58. This one, you do 42 divided by 58 equals second function sine. You should be getting the same thing. That is 46 degrees. So we get 46 degrees. Let's do this one. Inverse cosine. Adjacent over hypo. Adjacent is 40 over 58. Let's see what that gets us. Second function, cosine. 40 divided by 58. Over here, 40 divided by 58. Second function, cosine. You should be getting the same thing. 46 degrees. Last one, inverse tangent. Equals opposite. Our opposite was 42 degrees. Over adjacent, which was 42 units over 40. So this is inverse tangent, 42 over 40. Second function, tangent, 42 divided by 40. This one's 42 divided by 40, equal sign. Second function, tangent. Once again, the exact same thing. All three of these gives you 46 degrees. You're like, that's so much work. Well, once you realize you have a choice, you can choose the one you want. Now that you've seen it 3 times, you can see that you're going to get the exact same thing. Now, if you have to do all that for the other angle, well, no, because you're brilliant, students. You're going to realize that if this is 46 degrees and that's 90, to solve for this, for goodness sake, you don't need SOHCAH TOA. You just add and take away from 180. All right. This one you're doing completely on your own. Find all the angles and then go back and review. Ready? Pause. Welcome back. Let's see how you did. From this angle theta, the 20 is the adjacent, and the 48 is the hypo. So I have an AH combo. I'm going to use cosine. Inverse cosine. My A is 20. My H is 48. That's going to give us our angle right there. Nearest whole degree, that's 65 degrees. We have 65 degrees, and you simply take that away. If this is 90, these two together have to add up to 90. So you should figure out that this is simply going to be 25 degrees. Students, this was lesson 5.4, Inverse SOHCAH TOA, solving for angles.